Important questions from Narendra, Avasthi sir's physical chemistry. Redox reaction. Come on, let us discuss. The first question: when BrO3 minus ion reacts with Br minus in acidic medium, Br2 is liberated, the equivalent mass of Br2 in this reaction. See, whenever we are getting such kind of question, according to the statement, we have to write the equation so that it will be easy for us to understand. Okay, now that first point here, what it is, equation we have to write according to the statement. Second thing, you have to find out the oxidation number. Third thing, we have to identify whether increasing or decreasing, where it is increasing, where it is decreasing. According to that, we have to balance that equation. Then finally, we will get the correct exact answer. Okay, now first and foremost, equation, let us write BrO3, right here, BrO3 minus plus Br minus plus H plus, because this is acidic medium, so we are writing H plus, right? It gives Br2 plus H2O. Why I'm writing H2? Because it is acidic medium, it has mentioned. So 100% water molecule will be present, right? Now that first point we have written what it is, equation. Second thing, we have to find out the oxidation number. You know how to identify the oxidation very well, right? Okay, come on, let us find the oxidation number. This is BrO3 minus. Okay, so in that oxygen minus 2, you know very well. So minus 2 and here 3 it is there. So here minus 6 equal to plus 1, right? So this is minus, no? So your plus 1. So this X will be, so this X will be here plus 5 oxidation state. So the bromine, this bromine will be plus 5 oxidation. Whereas here 0 oxidation, elemental state, Br2, it is an elemental state. So plus 5, which is converted to 0. So that means it is converted plus 5 to 0. That means it is the reduction reaction. Reduction, right? And the same way here, another point, here Br minus is there, here 0. So Br minus means here minus 1 oxidation number, it is minus 1. Whereas here 0, the elemental state. So this is here what it is, 0 minus 1 to 0. So here bromine only, here plus 5 oxidation number, that is converted to 0, and the same time here Br minus, which is converted minus 1, which is converted to 0. So what kind of reaction? This is generally disproportionation reaction. What do we call this? Is disproportionation reaction. Disproportionation proportionation reaction, right? Okay, now we have to balance. Now first thing, we have to write the equation. Yes, we finished. Second thing, we have found the oxidation number. Yes, that is also we found. And third point, what we have to identify, where it is increasing, where it is decreasing. According to that, we have to balance it. Right now here, how many bromine is there? Here Br 1 bromine, here also bromine. Here 3 oxygen molecule is there. Okay, generally this is right hand side, this is left hand side, and this is right hand side, right? See, reactant, it is a left hand side, product, it is a right hand side, right? Okay, now how many oxygen atom is there? According to that, you have to put the water molecule. So here 3 oxygen is there, means here 3 water molecules. Okay, now here how many hydrogen atom is there? 6 hydrogen atom. So according to that, you have to put 6 hydrogen atom, H plus ion. So here 3 into 2, 6 hydrogen atom is there. According to that, you have to put 6 H plus ion. So oxygen and hydrogen balanced. Okay, now how many electrons it is reduced? That means plus 5 to 0. So that means electron, it is reduced. So the electron, actually 5 electron which is reduced. Whereas here is actually what it is, minus 1 to 0. Okay, now let us identify how many bromine atoms are available. Here 1 bromine, here 1 bromine, 2 bromines, but electron, how many electron? 5 electron. So that electron only we consider as here 5 bromine, right? So now how many bromine is available? 5 plus 1, 6 bromine is there. So 6 bromine atom means here 3 we put it. Okay, so now here in this point, here 6 bromine atoms are available, and here what it is, the reduction point from plus 5 to 0. Okay, now the next point, what we have to identify, the number of electron change. So the number of electron change, the number of electron change, right? So number of electron change only, it is called n factor, right? So number of electron change for the formation of 1 mole of bromine. So for the formation of 1 mole of bromine. So 1 mole of bromine, what it is? Here, from here what it is? 5, and from here what it is? 3. So that means 5 by 3. Okay, so now equivalent mass. They are asking about equivalent mass now. Okay, come on, let us identify the equivalent mass. The equivalent mass of bromine equal to how much? Molecular mass by n factor. N factor means what it is? number of electrons losing or gaining according to that reaction. So this is n factor, right? Okay, now here number of electrons exchange, right? So n factor, it is number of electron change. So here number of electron change means here what you will bring it here. See, so E bromine, right? E bromine equal to molecular mass by n factor. So here m, molecular mass is m, by n factor what it is? 5 by 3. So how can you bring it? 3m by 5. So which is the correct option? Option 3m by 5. So the answer, it is 3m by 5. How do we get it? That is easy. Only when you are, what it is? First thing, you are writing the equation and you are balancing that equation from left and right according to that number of electron change. That is according to that balancing equation only. Number of moles you are getting. So this n factor, number of electron change, that n factor only providing that what it is? Equivalent mass, that is equivalent mass equal to molecular mass by n factor. That only they are asking, equivalent mass of bromine. So 3m by 5. So according to this option, option C is the correct option. Hope you got the clarity about this equation. Okay, now the second question. This is, if MA gram of a metal A displaces MB gram of another metal B from its salt solution, that is actually MA, mass of atom, that is mass of A atom, gram of metal A displaces mass of atom B, gram of another metal B from its salt solution. And if the equivalent mass are EA and EB respectively, then equivalent mass of A can be expressed. So in that, which is the correct option? Okay, so this is very simple, easy, basic point they have given. In that way, we can identify. Okay, now here in this point, what they are asking about, asking mainly gram equivalence of A and gram equivalence of B. They mentioned that in a metal, right? So gram equivalence means what? That is nothing, molar mass by n factor. That's all. Okay, come on, let us identify. So the first point, what it is? Gram equivalent. So gram equivalent of A and gram equivalent of B. So equivalent, right? So gram equivalent of A, what we can write? Mass of A, that is molar mass of A, molecular mass of A divided by n factor, that is equivalent mass, right? Okay, here molecular mass, so I just mentioned molecular mass of A divided by n factor. So n factor I just mentioned EA, right? So EA, it has mentioned about A metal, right? That is what here they mentioned, no, EA and EB, that is what. The same way, gram equivalence of B, it is MB by EB. EB, it is nothing, n factor of B. So EA, EB, I just mentioned n factor of EA and n factor of EB. Okay, now here in this point, MA by EA, I just mentioned MA by EA. That is what it has mentioned, right? So MA by EA equal to MB by EB. This is very simple, easy. Okay, now they are asking in the question EA respectively, the equivalent mass of A can be expressed. So they are asking about what it is. EA only they are asking, right? So equivalent mass of A only they are asking. So EA, we can bring it out here, EB, right? This is EA, EB and MB. MA by EA equal to MB by EB. Now, in the question, they are asking about what it is? EA. So, EA, we just bring it out. EA equal to, how do we write this equation? MA by MB, right? Mass of A and mass of, molecular mass of A and molecular mass of B into equivalent mass of EB, right? So, that is what they are asking in that. So, MA by EA equal to MB by EB. So, this one we have to ask. So that means that is the question, we have to find out EA only. So when we bring it EA, MA by MB into EB. So this is the answer. So what is that answer? We have to identify EA equal to MA by MB into EB. I think you got an idea what type of question they are asking. How do we identify the answer? So what is which is the correct option? Option A. EA equal to MA by MB into EB. I hope you got the clarity. See, these are all very simple, logical way thinking. How do we identify? When you read the question twice or thrice, you will get the clarity, then you can bring the answer, right? Come on, these are all the conceptual question. Right now, come on, let's go to the next question. Hydrazine N2H4 reacts with the KiO3 in presence of HCl, as they have given the equation. So they are asking in the question the equivalent mass of N2H4 and KiO3 respectively. So what is that they are asking from this question? We have to find out the equivalent mass. So how to find out the equivalent mass? Equivalent mass equal to molecular mass by n factor. What is it n factor? How many electrons losing or gaining through this redox reaction? It's simple, easy. Come on, first and foremost, we have to write the equation. They themselves they have given. Second one, we have to identify the oxidation number. Third thing, what it is, how many electrons are losing or gaining. According to that, we have to identify the n factor. Come on. So here the first one, what it is? N2H4 hydrazine plus IO3 minus, that is KiO3, IO3 minus ionic equation they have given, plus H plus ion, it is acidic medium. So this is 2H plus they have given, plus Cl minus. So we are getting what it is? ICl. This is ICl plus N2 elemental state plus 3H2O. See here, 3 oxygen, 3H2O, right? Okay, how many oxygens are there? That many water molecules. How many oxygens are there in the left hand side? That many oxygens are there in the right hand side. So right hand side, it is a product side. Left hand side, it is a reactant side. Come on. Now, let us identify the second point, what I mentioned. Second point, it is we have to find out the oxidation number. How do we find out the oxidation number? Here, see, actually, what it is, hydrogen plus 1 oxidation state. So plus 1 means here 4 atoms are there. So 4 into 1, so that is plus 1. No, so here plus 4 oxidation number, whereas here plus 4 means here minus 4. Actually here 2 atoms are available, so divided by 2. So nitrogen, it is minus 2 oxidation number. So minus 2, which is converted to, here nitrogen is there, no, here 0 elemental state, it is 0. So minus 2, which is converted to 0. Now here IO3, let us identify. So IO3, what it is? Okay, this is minus, so that means oxygen, it is minus 2, right? So minus 2 into 3, so minus 6 is equal to plus 1. So here minus, no, that's what we are putting, plus 1. So minus 6 equal to plus 1. So naturally this is what it is, plus 5 oxidation state. How do we identify? Minus 6 minus plus 1, so that you are getting plus 5 oxidation. So plus 5 oxidation, which is converted to, here what it is? Cl. Usually Cl, it is minus 1. Cl minus 1 means iodine here plus 1, just to the opposite, plus 1. Right, so this is plus 1 oxidation. So plus 5, which is converted to plus 1. So here what it is? Minus 2 to 0, and here plus 5 to plus 1. So that means we have to identify what it is now, number of electrons losing or number of electrons gaining. Okay, now here what it is? Number of electrons, what it is? Plus 5 to plus 1. So here what it is? 4 electron change. How many electron change? 4 electron. Electrons losing or gaining, that is called n factor. So here for iodine point, it is 4 electron change, whereas here nitrogen atom, here how many electron change? 2 nitrogen atom into 2 electron change, minus 2 to 0. So 2 electron change. So this is 2 electrons. So altogether it is 4. Here also 4, and here also what it is? 4. Okay, now let us identify the equivalent mass of each. Okay, equivalent mass equal to what it is? Molecular mass by n factor. N factor. Okay, now equivalent mass of first one, what we are going to check it, hydrazine. So equivalent mass of hydrazine, right? Hey, what it is? N2H4. So N2H4 equal to how much? N2H4 here 14 into 2, so 28 plus 4, so altogether 32 gram per mole. So 32 gram per mole. So that means here what it is? 32, and here what it is? N factor, how much we have identified? Here 4, right? So divided by 4, so altogether here 8. For hydrazine, yes, we got it, hydrazine 8. And the second one, what it is? KiO3, the complete only, they have given that ionic equation IO3 minus, but in the question KiO3 only they have given. So KiO3, so KiO3, what is the equivalent mass? So equivalent mass of KiO3. So K, how much? Potassium, it is 39, plus iodine, it is 127, plus oxygen 16 into 3, 48. So altogether it is actually how much it is when you are adding all this? 214 gram per mole. Right. Okay. Divided by number of electron change. So here, how many number of electron change we have find out? Here 4 electron, right? So here plus 5, which is converted to plus 1. So here 4 electron only, right? So that means here divided by 4. So molecular mass by n factor, it is molecular mass by n factor, it is number of electron change. So here 4. So when you calculate this, so you will get the answer, what it is? 53.5 you will get. So 53.5. So that is gram equivalence, right? So here, so 53 and 8 and 53. So what is the answer you will find? So 8 and 53, the equivalent mass of hydrazine and KiO3 respectively. First one hydrazine, second one KiO3. So first one 8. Yes, we found 8 only here, right? That answer. So here 8, and the last one 53.5. Yes, option A is the correct option. Yes. Yeah, because of this auditors benefit, they are giving 4 answers now, so it is very easy to identify. If you know the concept and according to that, if you follow, definitely you will find the best correct answer. Right, come on, let us go to the next question. The next question, what will be the normality of a solution obtained by mixing 0.45 N and 0.60 N sodium hydroxide in the ratio 2 is to 1 by volume, right? Now here, normality of a solution. See, normality, it is actually what it is. I just bring that because both two solutions are there. So normality mix. So they are asking about normality mix equal to N1B1 plus N2B2 divided by B1 plus B2, right? So this is actually what it is, main concept of this question. So how to identify here? Normality mix equal to N1 V1 plus N2 V2 by V1 plus V2. So they have given that normality. Actually, this is one point and this is another point of sodium hydroxide. In the volume, what they have given, ratio 2 is to 1 by volume. Yes, come on, let us identify N1 and N2. So here what it is, N1, what they have given, N1 equal to 0.5, 0.45 N1, right? Okay, now N2, what it is, N2 equal to, this is 0.60 n. This is n only, not n1, n1. Okay, so here in this point, here n only. So this is n1 and n2. Right, now the second one here actually V1 and V2. So V1, how much they are giving? V1 and V2. So according to that, what the ratio they have given? 2 is to 1. So here 2 and here 1. Okay. So N1 also we got it. N2 also we got it. V1 and V2. Okay, come on. Let us apply the value in the equation. So here 0.45 into 0.45, right? Here 0.45 into 2 volume, this is N and this is V, plus 0.60 into 1, that is volume V. Here N, this is N and this is V, and same way here this is N and this is V, divided by V1 and V2. So 2 plus 1. So while calculating, what do you got it? So here 45 is actually 0.45 into 2. So you will get what it is, 45 into 2. So then that is 90. In that way you can bring it. So here you will get what it is, 0.90 plus 60, right? So here 0.60 divided by 3. Simple. See, calculation and all, make it a simple number, so it will be easy for you to understand, and calculation also it will be easy. Okay, now how much you will get it? 1.50, no, 9 plus 6, here 15. So 1.50 divided by 3. So what is it? 3 5s are 15, right? So 3 5s are 15. Here, digits way, no, 0.50 n. So this is the answer. So the normality obtained the solution, it is 0.50 n. Yes. So normality mix, this is normality mix equal to this is. I hope you got the clarity. How do we identify? Usually even two solution, when they are giving comparative way, V1 and V2, like M1 and M2, and the same way N1 and N2, this is also N1 and N2. So in that way you can bring it. I hope you got the clarity. See, N1 N2 and the same way volume ratio they have given. So first one, it is V1 and V2 in that way. So which is the correct option? 0.50, no? So option B, 0.5 n, right? So this is B option, it is the correct option. I hope you got the clarity. Yes, come on, let's go to the next question. The next question, a solution containing 2.7 into 10 to the power of minus 3 mole of A2 plus ion required 1.6 into 10 to the power of minus 3 mole of MnO4 minus for the oxidation of A2 plus 2, AO3 minus, the medium is used. Actually, here reactant is equivalent to product. Just will verify this answer. Equivalence of A, that is equivalent to equivalence of B. That is what I just bring for this question. That is a concept actually. Come on, let us write the data here. Actually, A2 plus, right? So A2 plus equal to 2.7 into 10 to the power of minus 3 mole, right? And the second one, what it is, MnO4 minus, right? MnO4 minus, right? So MnO4 minus equal to 1.6 into 10 to the power of minus 3 mole. So when you divide this, you will get the answer. But still, we need the proof to identify the answer. Okay, come on, let us go here. Oxidation number we have to identify, no? So AO3, so this is actually A2 plus, which is converted to AO3 minus. That is what here they have given, no? AO3 minus. So what is the oxidation number over here? So this is plus 2, but here what it is, here oxygen, it is minus 2, no? So here minus 6 equal to plus 1. So that means this is plus 5. So plus 5. So plus 2, which is converted to plus 5. So that means how many electron change? Here 3 electron change. Okay, now 3 electron change means how do we identify whether it is a acidic medium or basic medium? I would like to give that idea, that is reactant is equivalent to product. I just mentioned, no? So that is balancing equation. According to that, this is one more concept and idea. Equivalent of A2 plus, equivalent of A2 plus is equal to equivalent of MnO4 minus. So this is one more concept. So equivalent of A2 plus equal to equivalent of MnO4. So because this is oxidation reduction, both it's simultaneously it is taking place now. So this many electrons are losing, that many electrons are gaining from that side. So that is what here the main concept is, that only. Okay, I just bring it here. 2.7 into 10 to the power of minus 3, right? Mole into n factor. How many n electrons it is provided? 3 electrons is equal to equivalent of Mn over. This is only we have to identify whether it is acidic medium or basic medium, right? So here in this point, 1.6 into 10 to the power of minus 3 into n factor, we have to identify n factor. So n factor, we bring it this side. So n factor is equal to n factor. N factor we bring this side. So 2.7 into 10 to the power of minus 3 divided by what it is. This one, this 1.6 into 10 to the power of minus 3. N factor, we just bring it there only. So here 2.7 into this, into 3 electrons. 3 electrons only, no, here. So 3 electrons divided by this. Okay, n factor only, we bring it here. So what is the answer here? How do we bring it? So this and this will be cancelled. Minus 3 will be cancelled. So 10 to the power of minus 3, 10 to the power of minus 3. So 2.7 into 3. So how do we bring 2.7 into 3? Here equivalent of A2 plus equal to equivalent of MnO4 minus, that is A equivalent to B. That same idea. So here n factor also we have to identify. Okay, so 27, that is 27, 2.7 into 3 divided by 1.6. So what is the answer? 81, right? So 81 divided by 1.6. So what is the answer you are getting? Come on, calculate it. When you're calculating, this is approximately 5 you will get it. So that means n factor of MnO4, what it is, 5 electrons. So 5 electrons means, come on, let us check whether this answer is correct or not. Usually we will check always the answer. So MnO4, here MnO4 minus converted to Mn2 plus, then only we can identify 5 electrons. So here actually oxidation number, right, we have to identify. So oxidation number, what it is here, 2, no oxygen, usually minus 2. So that is minus 8 equal to plus 1. So this is minus, no, plus 1. So that means here what it is, plus 7. So plus 7 which is converted to plus 2 means 100% here 5 electron change. 5 electron change means actually this is what it is, acidic medium only, because we have gone through n number of questions, that is n number of examples. So 5 electrons. Okay, now let us check another one more idea, right? So this is actually acidic medium only. Yeah, so here MnO4 minus, I'm giving the proof, MnO4 minus plus, here how many electron change? Here 5 electron change, right? Plus H plus ion, acidic medium only. So you will get what it is, Mn2 plus plus H2O. How many water molecules? Come on, can you guess how many water molecules? Here 4 oxygen atom is there. That means 4 water molecule. How many oxygen atom is there? That many water molecules. Right. Now, how many hydrogen atom it is there? That many H plus ion. Okay, so how many electron change? It is 5 electron change. So 100% this is actually what it is, plus 5 oxidation. Now, let us identify both. Okay, A2 plus plus 3H2O. It gives AiO3. That is actually AiO3. Now, AO3 minus plus 6H plus ion plus electron. How many electron? 3 electron. This is only we found first, right? Okay, so moles ratio. So moles ratio, what it is? Moles ratio equal to moles ratio equal to A2 plus divided by MnO4 minus. So here what it is? 2.7 into 10 to the power of minus 3, 10 to the power of minus 3 divided by 1.6 into 10 to the power of minus 3. This and this will be cancelled. So when you calculate 2.7 divided by 1.6, so approximately what you will get it, 1.687. Okay, 1.6875 also will be getting 3 points enough. Right. Okay. Now the same electron change, how much we got it? So here actually what it is, 5 electron by 3 electron. How much you are getting? Here also more or less what it is, 1.667. So 1.667 here, 1.6 what it is, 87. More or less equal. Actually it is similar. I mean similar to that. Nearer to that, right? Okay, so which is the correct option? You're bringing that directly, would have got it actually. So how do we got it? 2.7 divided by 1.6, we would have got it, but still we need idea. We have to go for that concept according to that. So actually this is acidic. So how do we bring that it is acidic? Because here electrons, the same idea we are bringing. So here 2.7 divided by 1.6. In that way also we can bring, or else here 5 electron change, 5 divided by 3 electron change. In that way also we can bring. So 5 electron, how do we get it? That is because of electron change. through oxidation reduction n factor we identified. So through that only. So how acidic medium, how many electron it can reduce, basic medium, how many electrons it can bring it out. So in that way we can identify 3 and 5, right? I hope you got the clarity according to this concept. Come on, let's go to the next question. So which is the correct option? Acidic medium. Basic medium, it is totally different. Okay, all right, come on. When the question comes for basic medium, that time I'll explain about this point. The next question, hydrogen peroxide is used as a bleaching reagent because on dissociation it gives oxygen. H2O2, it gives H2O plus half O2. So in that related question they are asking, Chechi 420 used H2O2, hydrogen peroxide solution, to bleach her hair, and she required 2.24 liter of oxygen gas at 1 atmospheric pressure and 273 Kelvin. She has a hydrogen peroxide solution labeled as 5.6 volume. Then what volume of such solution must she required to bleach her hair? So here very clearly they mentioned she required 2.24 liter oxygen gas, and they have given the condition hydrogen peroxide solution labeled as 5.6. Then what volume of such solution must required to bleach her hair? Okay, maybe her hair is very long and thick. That is what they are asking, such kind of questions and all. What is it? Chechi 420, right? Okay, come on. Let us identify the volume of hydrogen peroxide. So volume of hydrogen peroxide, let us go in this way. Actually volume of here, actually volume of H2O2 divided by volume of oxygen. So here volume of hydrogen peroxide 1 liter, let us think 1 liter of hydrogen peroxide divided by 5.6 liter of oxygen, right? Okay, so here in this point, according to this calculation, to find that hydrogen peroxide only, no, so to find hydrogen peroxide H2O2 equal to a volume of oxygen into 1 liter of hydrogen peroxide divided by 1 liter of what it is, a 5.6 liter of oxygen, right? Now here we just apply the value in ml because the options they have given ml only. Okay, now in that way here what it is, 1000 ml divided by 5.6 into 1000, so 5600 ml into 2.24 into 1000, so that means 2024, that is actually 400, right? Yeah, 2.24 into 1000, right? So when you are calculating this, so what is the answer you will be getting? You will be getting 400 ml. Actually the option it is 400 ml only, right? Okay, come on, we just check in that here, right? So here 400 ml, option C is the correct option. I hope you got the clarity. How do we go for it? Because everywhere it is ml only, just to be converted into ml. So volume, how do we identify? I hope you got the clarity. I think Chechi's hair, it is what to say, thick hair only, 400 ml she required. It is related nearly, it is 5.5 liter it is required. Okay, come on, let's go to the next question. 10 ml of NHCl, 20 ml of N by 2 H2SO4, and 30 ml of N by 3 HNO3. Here in this question, N by 1 HCl, N by 2 H2SO4, N by 3 HNO3, yes, are mixed together and volume made to 1 liter, right? So this is 1 liter total volume. So the normality of H plus ion and the resulting solution. Okay, fine. This is very simple actually. Here they have given actually what it is, the concept of normality into volume. So normality only, no? So here milli equivalence, right? So here milli equivalence, equivalent, that is milli equivalent is equal to normality into volume. This is the concept, right? Okay, now here milli equivalence, what they are, what I'm mentioning here, it is milli equivalent of HCl equal to 1 N into actually what it is, 10 ml, right? So that is what it has mentioned, 10 ml, 20 ml, 30 ml. That is what I just mentioned, milli equivalent. Just I would have mentioned here equivalent, but here they are mentioning ml, no? So milli equivalent equal to normality into volume. So you have to multiply with that 1 n into 10 ml, 2 n into 20 ml, 3 n into, that is the way. So here 1 n, here n by 2 it has mentioned, that means half, right? So here HCl, it is actually 1 n into what it is, 10 ml. And the next one, what it is, milli equivalent of H2SO4, right? Second one H2SO4 only, no? H2SO4, right? H2SO4. So H2SO4 here, what it is, here half n, n by 2 it has mentioned, no? Half n into how much it is here, 20 ml, 20 ml. And the next one, what it is, milli equivalent of HNO3, HNO3 equal to, here what it is, n by n by 3. So n by 3 means what it is? 1 by 3 n. 1 by 3 n into 30 ml. Right, here 30 ml only, right? 30 ml. Now what is the answer you are getting over here? So here what it is? 1 n. So 1 n means what it is? 10. 10 milli equivalent. Right, now here what it is? This and this will be cancelled. Here also 10, I mean milli equivalent. 10 only you are getting. And here this and this will be cancelled. Here also 10 milli equivalent. Here main concept you just remember, this is normality into volume if they are giving such kind of question. Normality into volume. Yes. Now the next point what it is? Total volume they have given now. So all the volume mixed together and volume made 1 liter. So the total volume they have given what it is? 1 liter. So what is the point we can bring it? Total milli equivalent. Total milli equivalent is equal to milli equivalent of HCl and plus milli equivalent of H2SO4 plus milli equivalent of HNO3. So now here total milli equivalent divided by total volume. Total volume. Here total volume, how much they have given? Total volume 1 liter, right? 1 liter only they have given. So 1 liter only they have given, right? So here 1 liter. So in that point, how do we bring it? So here 10, here 10, here 10. The answer you are getting what it is? 10, 10, 10. That is what we got it now. So that means here 30 ml. We are bringing the point ml only, right? So here 30 ml. Liter. Here total volume liter only it has given now. So that is also we converted into ml. So that means 1000 ml, right? So that means how much you'll be getting here? This and this will be cancelled. So 3 by 100, right? So 3 by 100. And here actually what it is? What is the answer here? Normality. Normality. So normality only we are bringing. That is 3 by 100. So what is the unit over here? N. So 3 by 100. They are asking that volume only. So this is actually total milli equivalent. It is actually these divided by total volume. So this is normality. Normality. So normality equal to total milli equivalent divided by total volume of the solution. So normality, what is it? The answer it is 3n by 100. Yes, correct. 3n by 100 is the correct answer. Option A is the correct answer. Come on, let's go to the next question. The next question, 0.45 gram of an acid of mole, that is molecular mass 90 was neutralized by 20 ml of 0.54 n, that is normality of caustic potash. KOH, the basicity of acid. Actually, this is a neutralization point. That is actually acid plus base, the salt and water neutralization. Okay, now in this given mass of an acid, that is 0.45 gram of an acid of molecular mass they have given. But the other one, what is the data they have given? 20 ml of 0.54 n caustic potash, KOH. So what is the basicity of acid? Molecular mass they have given and given mass they have given. Basicity they are asking. Come on. So this is actually neutralization reaction. No, so neutralization reaction means here they are asking about that what it is, basicity of acid. So basicity of acid means actually n factor we have to identify. What do you mean by n factor here? Not only number of electron change here, H plus ion, OH minus ion, replaces of H plus and OH minus ion also here included n factor, right? That is what. So neutralization. This is second question. So neutralization. So neutralization is equal to what it is? Acid and base. That you know very well. But here I just bring it another one more point also. Here number of equivalent of acid. Number of equivalent of an acid is equal to number of equivalent of base, right? So this point, it is very, very important. So equivalent of an acid is equal to equivalent of a base. So in this point, equivalent of KOH, come on, because equivalent of base, if we identify, this will be easy for us, right? So equivalent of base, because they have given what it is, values they have given, normality they have given, no. So equivalent of KOH is equal to normality into volume. Just now I just mentioned, no, volume, normality into volume. So equivalent is equal to normality into volume. So normality, how much they have provided? 0.54 normality into 20 ml. What is it? 20 ml. Volume, it is 20 ml. So how much you are getting the answer? You are getting the answer actually 0.0108 equivalent, right? Equivalent only, right? Equivalent. Equivalent. Right. So, okay. Now here, equivalent of acid we have to identify. Just equivalent of base we got it. Equivalent of acid is equal to equivalent of base. No. So, I just bring it here clearly. Equivalent of acid is equal to equivalent of base. Right. Okay. Equivalent of base. Right. Now here, that is how much? 0.0108. Right. That is only right. Yeah. Equivalent. Equivalent. Right. Okay. Now equivalent of acid. Now we have to identify. So equivalent of acid. How much here? They have given mass, right? So equivalent of acid, because they have given mass, right? So given mass how much? 0.45. No. So here mass of an acid divided by equivalent of an acid. Equivalent of an acid. So mass of an acid, how much? 0.45, right? Yeah, 0.45. So 0.45 divided by equivalent of an acid is equal to equivalent of a base, right? So that means 0.0108 equivalent, right? This is a gram and this is equivalent. So what is the answer you will get when you calculate it? So equivalent of an acid, what is the answer you'll be getting here? 41.67 gram equivalent. Gram per equivalent. Right. Okay. Now, next point, what we are going to check it, basicity. Now, we got both the answer. So, basicity is equal to basicity of an acid. Basicity only, it is an acid only we are concluding. Right. So, basicity of an acid. So, what is that point you will bring? Equivalent of an acid, molecular mass of acid by equivalent of equivalent weight of acid. So, molecular mass here, molecular mass of an acid, how much it is? 90, right? And equivalent weight of an acid. So what is it? Weight, just now we got it. Now equivalent of an acid, here mass, I just bring it, equivalent mass. Okay, equivalent mass of an acid. So equivalent mass of an acid only we are bringing. So mass of an acid divided by equivalent of an acid. So here basicity is indirectly we are talking about what it is, equivalent mass of basicity only. So here that is what I just mentioned. Equivalent, what is that point we are bringing? N factor. N factor means what it is? H plus ion, OH minus ion replacing. So basicity H plus ion only, right? So here, so in this point here, what it is, 90 gram they mentioned, molecular mass of an acid, it is 90 gram per mole, right? So 90 divided by, here what it is, 41.67 gram per equivalent, here gram per mole. So here, what is that answer you'll be getting? Gram will be cancelled. So here, what it is, when you calculate 90 by 41, so 45 plus 45, 90. So that means more or less you will get the answer here, 2. You will get it now. So basicity nearly 2. So when you calculate now here, 2.16 you'll be getting. So more or less here what it is, 2 you'll be getting. So basicity. So what is the basicity of an acid? So basicity of an acid, H plus ion, will be what it is. Here 2 will be the correct answer. So the answer it is, very long point. The answer it is 2. Yes. The answer is to B. Yeah, this answer. Both the question I just mentioned in one point. No, so that is it. Okay, come on. I hope you got the clarity. How do we identify? Same kind of question. That is what I just bring. Normality into volume. So that is equivalent mass. So here milli equivalent they are mentioning in this concept. And here the same idea, I just bring it over here. Okay, come on. Let's go to the next question. The next question. A 3.4 gram sample of H2O2 solution containing X percentage hydrogen peroxide by mass requires X ml of KMnO4 solution. A complete oxidation under acidic condition, the molarity of KMnO4 solution. Right. Okay. Now here in this question, KMnO4 combined with the hydrogen peroxide, it gives how much ml requires of what it is, KMnO4. Molarity, the question they are asking. And here given mass, that is what it is, 3.4 gram sample of H2O2 solution. Percentage mass it is they have given. Okay, so number of moles we have to identify. The same way we have to identify KMnO4 also, right? Come on, let us identify. So to identify the molarity, that means to find out the molarity of KMnO4, we use this principle. What principle actually? Number of equivalents of oxidizing agent is equal to number of equivalent of reducing agent. Okay, now I just mentioned the principle, right? So to find out molarity of KMnO4. So generally, okay, I just mentioned according to this question, KMnO4. So here number of equivalent of oxidizing agent is equal to number of equivalent of reducing agent. I just mentioned in this way. Okay, so number of equivalent of oxidizing agent, OA oxidizing agent, is equal to number of equivalent of reducing agent. Okay, now I just bring according to that data so that it will be easy for us to identify very well, right? So the mass of the sample, it's X percentage hydrogen peroxide by mass. Okay, so mass of sample hydrogen peroxide. So it is, they have given X percentage, right? So X percentage by mass, that is actually how much it is, like 3.4 gram. So X percentage they have given, no? So X by 100 percentage they have given, X by 100. So mass of its sample hydrogen peroxide solution, sample it is what containing X percentage of hydrogen peroxide by mass. Right now, here number of moles we have to identify. So the moles of hydrogen peroxide. How do we identify moles of hydrogen peroxide? Okay, now what is the answer? While calculating this, so this is actually what it is: 0.034 x gram. So this is a given mass. Okay, so moles of H2O2. So the moles of H2O2. I hope you got an idea why I just bring that mass of the sample 3.4 gram, X percentage of that solution they mentioned. So that is what 3.4 gram X by 100. So that you are getting the given mass. So given mass by molecular mass only, number of moles. So here what it is, given mass 0.034 X. That is the X solution divided by molecular mass of hydrogen peroxide. This is 16 plus 16 into 2, right? So this is 32 into 2. So 34 gram per mole. So this is also gram. Okay, so this gram and gram will be cancelled. So the answer it is 0.001 x mole. Right, so this gram cancel. Right, now the next point. So number of moles of hydrogen peroxide we found. Now what we have to identify? Moles of KMnO4. Moles of KMnO4 we did not know. How do we identify? Let us write the equation so that you will come to know that number of moles. So moles of KMnO4, KMnO4, potassium permanganate, that is equal to. So how do we identify KMnO4 plus what it is? Here hydrogen peroxide. Hydrogen peroxide. I will write the equation so that it will be easy to identify number of moles. How to? And this is acidic medium they mentioned. So this is H2SO4. So it gives here K2SO4, K2SO4 plus next one, what it is? MnSO4 plus O2 plus H2O. Right. Okay, now let us balance that equation. So as we come to know that equally, here actually how many potassium it is there? 2 potassium, so that we can put it 2 over here. Hydrogen peroxide and H2SO4, here K2SO4 and MnSO4 is available. So that means here, well, balancing this equation, here 5 H2O2 and 3 H2SO4, here K2SO4 plus 2 MnSO4 and 5 O2 and 8 H2O. Yeah, yes, while balancing we will come to know that. Now let us check that what is it, finding the solution of this. So here how many moles reacted, how many moles of hydrogen peroxide, that we have to check it, because here number of moles we found, here hydrogen peroxide number of moles we found. Now number of moles of KMnO4 we have to check. That is what this equation we brought it. Okay, so number of moles of KMnO4 equal to moles of hydrogen peroxide. Okay, so moles of KMnO4, moles of KMnO4 equal to moles of hydrogen peroxide into 2 mole of KMnO4 divided by 5 mole of H2O2. Right. Okay. Now let us check this point. So moles of KMnO4, what is that we have found here? Moles of KMnO4. In this, I'll write it here. Moles of KMnO4. KMnO4 equal to 0.001 x into 2 by 5. Yes, 2 by 5 only, no. So here moles of KMnO4, that is moles of H2O2 into 2 by 5. So while calculating, we are going to get, what is the answer? We will get 0.0004 x mole. I hope you got that idea. From moles of H2SO4, we got this answer. And well, what it is, writing that equation, balancing equation, stoichiometric coefficient of KMnO4 and H2O2, we are getting this point. So we are getting that moles of KMnO4. Right, now next point, what we are going to say, volume of KMnO4. So volume we have to identify. So volume of KMNO4. So volume of KMNO4, what it is, we keep it as a XML. Right. Now here in that X by volume in liter, so that is 1000 ml. Here also we put it 1000. So now we can check the molarity. So what is that molarity? So molarity, it is now volume of the KMNO4 also we got it. Moles of the KMNO4 also we got it. Now molarity is equal to molarity equal to what it is? Number of moles of solute, number of moles of solute divided by volume of solution in liter. Right. Okay. Now let us apply the value. Number of moles of solute. How much we got it? Here actually 0.0004x divided by volume of solution in liter. How much? X by 1000. You know why this X we mentioned? Volume of solution XML in liter. Volume of solute in liter. So that is X. So when we are calculating this 1000 will go upwards. So that means 0.0004x into 1000 divided by X. Now this X and this X will be cancelled. Now this X, how do we get it? That is from that question only. It is there mentioned X, that point. Okay. Now 0.004 into 1000. So you will get how much? You will get 0.4 molarity. Why? I just put it capital M. This is molarity of KMNO4. This molarity only we are deciding, right? So molarity, it is actually KMNO4 only. So molarity of KMNO4. I hope you got the clarity. How do we bring this point? Okay, so first and foremost, from the data, we are collecting the number of moles of hydrogen peroxide. Then we are collecting a number of moles of KMNO4. We are collecting from stoichiometric coefficient. Now both we are finding, this is the mole ratio. So both we are finding, and finally we are concluding that molarity. So we are getting like this. I hope you got the clarity. How do we find this answer? Yes, this is going around the neck like, but it is easy to identify. Now what is the answer? 0.4 is the correct option. Yes, this is the correct option. Hope you got the clarity. Come on, let's go to the next question. Now the next question, what volume of oxygen gas measured at 1 atmospheric pressure and 273 Kelvin will be formed by action of 100 ml of 0.5 N KMNO4 on hydrogen peroxide in an acidic solution? The skeleton equation for this reaction is, so they have given that equation. Now they are asking about that volume of oxygen. See what volume of oxygen gas measured. They have given the condition. So that means 22.4 liter. That is the way we have to bring it out, that point. Now volume of KMNO4 they have provided, that is 100 ml of that is, and normality also they provided. Okay, now let me write this equation clearly here. So it will be easy for us to balance that equation. Now here KMNO4 plus H2SO4. The last equation same only. Now here H2O2, it gives K2SO4 plus MnSO4 plus O2 plus water. Now here balancing equation the same, like here K2 is there, no, so to K, and here 5 H2O2, the hydrogen peroxide, and here 3 H2SO4. So you will get K2SO4, yeah, 2, 2, it's there. MnSO4, here also 2, so here 2. And here 5 O2 and 8 H2O. You just check, all will be equal. Product, reactant, all both will be equal. Yes, balanced. Right, now here, let us find out the answer for this question. So here volume of the KMNO4, let me write that, what is it, data. So volume of KMNO4. Volume of KMNO4, how much we got it here? 100 ml, right? So in the question we read, it is 100 ml. So we can convert it into liter, that is 0.1 liter. Right. Now that normality of KMNO4, normality of KMNO4. So normality of KMNO4, here only we have seen 0.5. See now here, this arrow 0.5. So 0.5 N, right? So here 0.5 N. Right. Now, here number of equivalent of KMNO4. Now we have to check it. So number of equivalent of KMNO4. So what is it in number of? So here normality into volume of solution. That is it. What it is? Normality into volume of solution. Right. So normality how much? 0.5 N. Into volume of solution 0.1 liter. See here, that is what I just bring the data. See, usually if we write the data, no, it will be easy for us to calculate because we know the formula. So according to that, we can apply the value. Right now here, so what is the answer? You will be getting 0.05 equivalent, right, of KMNO4. So now here in redox reaction, whatever reactant that is equivalent to product. So here in redox reaction, number of number of number of equivalent of reactant is equal to number of equivalent of product. Right. So reactant is equivalent to product, generally equation. So here equivalent of reactant is equal to equivalent of product, even in that redox reaction also. Right now here number of equivalent of oxygen gas also. Therefore here number of equivalent of KMnO4 is equivalent to number of equivalent of oxygen. That is what I wanted to bring it. So number of equivalent of oxygen gas formed. So here KMnO4, here oxygen. Now you see here in this equation, number of equivalent of product, not moles here, equivalent we have to consider. So in this point, in number of equivalent of KMnO4, it is 0.05, and the same way number of equivalent of oxygen also 0.05. That is what I just wanted to bring from this concept. Right now we got it, number of equivalent. Now directly we can go and identify the equivalent mass. Now what is it? Equivalent mass, molecular mass by n factor, right? So here equivalent of mass, equivalent mass equal to molecular mass by n factor. So molecular mass by n factor, what it is? 22.4 divided by n factor. How many electron change here? I just wanted to bring this equation only. N factor, I just bring it here in this equation. So H2O2 only, no oxygen. When oxygen, from where it is coming? Oxygen. H2O2. So here in this, here -4. Right? Here -4. That means here +4. How do we get +4? Hydrogen 1. So here, and that means 4 is there, no? So that is +1, right? Okay, yeah, it is 4, -4 and +4, right? Now here in this oxygen, 0, element 0. So here actually from -4 to 0. So that means here what it is? 4 electron change. Right. So n factor, it is number of electron change only, no? So number of electron change here, n factor we are bringing, no? So number of electron change, it is 4. So when you are calculating 22.4 liter per mole, why do we bring 22 point liter per mole? It is molecular mass, I just mentioned. Actually molar volume. Why I mentioned molar volume here? What it is? Equivalent of oxygen. So oxygen, what is it? They mentioned conditions, gaseous thing, no? Conditions, that is 22.4 liter. What it is? At temperature and pressure, and also molar volume also we can. So molar volume by n factor. Suppose if it is molecule, means molecular mass by n factor. Here molar volume by n factor. Molar volume, it is 22.4. I hope you got the clarity. Generally we use say molecular mass, no? So that flow I just meant bring it. Here molar volume we have to bring. Why? Because it has given that conditions at STP. So at STP means 22.4 liter, gaseous points we have to bring it, right? Okay. Now when we are calculating this 5.6, here what is it? Equivalence, we will get it, right? 5.6 liter by equivalent. Right. Now here 5.6 we got it, no? Okay. Now finally we are coming to that conclusion. So what is that conclusion? Total volume of oxygen. Total volume of oxygen. Total volume of oxygen gas. How much? Number of equivalent of oxygen into volume per equivalent at STP. Volume per equivalent at STP. So here how can we calculate it? 0.05, that is number of equivalent of oxygen into, this is per equivalent. That means here this point 5.6 liter, no? So equivalent of mass, that is per equivalent at STP. So that is what molar volume we brought it, no? 22.4 liter. That is what is the answer? 5.6 liter per equivalent. So when you are calculating, you will get the answer here, volume of oxygen equal to, so the answer will be 0. Here it is 0.28 liter. Okay, so this is the value. Okay, come on, let us check the answer. So here the option it is option it is B. B is the correct option, 0.028 liter. But here we got the answer 0.28. Yes, we observed everything here. 100 ml, so 0.1 liter. Here normality in the question 0.5 they have given. Yes, in the question it is given 0.5 only. Yes, 0.5, 1 liter. Yes, normality equal to, yes, we calculated 0.5 n, and so you're getting 0.05. Yes, equivalent of KMnO4. So equivalent of KMnO4 is equal to equivalent of oxygen. Yes, that is also we found it. And the molar volume, it is 22.4 liter divided by 4. So here you're getting 0.56. So number of electron change, it is n factor, no? So that is n 4 only. So 22.4 divided by 4, we are getting 0.6, 5.6 only. Yes, now we are calculating total volume of gas 0.05 into 5.6. You are getting 0.28 liter only. How do we get 0. Okay, maybe the question what we are calculating it is correct only. So the option sometimes it may be wrong. Okay, yes, come on, let's go to the next question. I hope you got the clarity. How do we identify that volume? Suppose they are asking molar volume. If they are giving all this, what to say, temperature, pressure means molar volume 22.4 liter. You can bring it. I hope you got the clarity. Come on, let's go to the next question. Next question. KMnO4 reacts with oxalic acid according to this equation. 2MnO4 minus plus 5 oxalate, that is C2O4 2 minus plus 16H plus ion. You're getting 2Mn 2 plus 10 CO2 plus 8 H2O. See here also 4 oxygen is there. No, so 4 oxygen means how many oxygens are there? That many water molecules. So 4. Here 8. 2 is there, no, 2 MnO4. So that means 8 oxygen, 8 water molecules. And 16, A2s are 16, 16H plus ion. So in that way only, right? So here, now come to this point. I just bring that idea for you how to balance that equation, right? Okay, now come to this point in this equation. Here 20 ml of 0.1 m KMnO4 is equivalent to. See, indirectly they are asking about what it is. Equivalent, actually they have given the volume of solution, volume of the solution also they have given, molarity also they have given. Indirectly they are asking number of moles. So here in the balancing equation only they are mentioning about 2 moles of KMnO4 requires 5 moles of oxalic acid. That means 20 ml of KMnO4 what it is, how many moles requires of 0.1 m KMnO4, that only as a question. Now they have given the option, according to that which option is correct. Now in this question we have to find out number of moles only, because volume they have provided, molarity also they have provided. Now we have to identify number of moles. So molarity is equal to what it is, number of moles of solute divided by volume of solution in liter. So volume of solution in liter, that is actually it has given 20 ml, millimoles there, liter they have given. Right, now molarity also they have given. Now we have to identify number of moles. Right, I think I have given a clarity for you to understand this question. Okay, now here 2 moles of KMnO4 requires 2 moles of KMnO4 requires 5 moles of oxalic acid. Oxalic acid, right? So that means here 20 ml. That means here 20 ml. This is 20 ml of 0.1 m KMnO4. KMnO4. Equivalent to. So that means here what it is, very clearly they have provided the equation in that. Here only it has mentioned very clearly, so nothing to write it once again. Yeah, now molarity, directly we can go that point. Molarity equal to number of moles of solute divided by volume of solution in liter. Volume of solution in liter, right? Okay, now here what it is, molarity they have given 0.1. 0.1 into number of moles, we can make it as a x, divided by volume of solution in liter, that is 20 ml. No, so 20 divided by what it is, 1000. So here we can bring it what it is, moles, number of moles of KMnO4. That's what starting only I mentioned. Indirectly they are asking the moles, because molarity they have given, volume of solution also they have given. Now this only we have to identify, number of moles equal to these two we can multiply. So what we are getting, 0.002 mole, right? Now we have to check in this what is it, option which is that correct. So that means here which is equivalent. Now this is which is equivalent they are asking. Note the point here, 20 ml of 0.1 m KMnO4 is equivalent to, which is the correct option. That is based on what it is, number of moles of oxalic acid we have to identify which is equivalent to that KMnO4, 20 ml of 0.1 m KMnO4, which is equivalent to this, what it is. For that we have to identify what it is, number of moles of oxalic acid. For that we have to see the moles ratio. So here 2 moles of KMnO4 requires 5 moles of oxalic acid. So in that way here KMnO4 what it is here, I just bring it, KMnO4 actually 2 moles, and oxalic acid H2C2O4 actually here 5 moles. So 2 moles of KMnO4 reacts with 5 moles of oxalic acid. So number of moles of oxalic acid we have to identify. So number of moles of KMnO4 we found just now. We found this is number of moles of KMnO4. Now we have to identify number of moles of oxalic acid, so that we can identify the clarity from this option. So here number of moles of oxalic acid H2C2O4. That means here what it is, number of moles of KMnO4, number of moles of KMnO4 into See, moles ratio we have to identify. What is it moles ratio? 5 moles 5 moles of oxalic acid divided by 2 moles of KMnO4. Right. So here number of moles of KMnO4 0.002, right? 0.002 mole into 5 by 2. So what is the answer? You will be getting 0.005 mole. So this answer you have to get it. I hope you got the clarity. How do we bring this answer? First and foremost, we have to see the number of moles of KMnO4 and then moles ratio of the equation. Moles ratio of the equation, how many moles requires for how many moles to oxidize, and we have to check according to that equivalent option. So here in this point 0.005 only answer should be coming. The answer should be what it is, 0.005, that is the moles of oxalic acid. Okay, so what is the answer? You're getting 0.005 moles. Answer should be coming. Come on, the options I have written clearly over here. So here what they have given, volume they have given and molarity they have given. When we calculate volume and molarity, we will get number of moles. That's all simple. Okay, now here ml only they have provided. We converted into liter. So how do we convert it into liter? 120. So ml no, so we just converted into 0. What it is? 120, right? 0.120. So that means into 0.25 molarity as it is same, only volume ml we have to change into liter. This is liter. So what is the answer you will be getting? 0.03 mole. I just mentioned here. Now the second one, what it is? 0. What it is? 10. Oh, sorry, 0.515, 150, right? 0.15 into 0.1 m. This is liter into molarity. This is molarity, capital M. So you will be getting answer 0.015 mole. Right, and the third option 0. What it is, 25 ml, no, 0.25 directly we just 0.25 into molarity, how much here, 0.2, right? So how much we are getting here? 0.05 mole. So 3 option also wrong, right? The last one, what it is, 50 ml, so 0.5 into, that is liter, into 0.1 m, this is 0.1. So you are getting what it is, 0.005. Yes, we got it, the answer. So 0.0, option D is the correct option. 50 ml of 0.1 m H2C2O4 you will be getting what it is, 0.005 mole. So that is actually equivalent to KMnO4 moles. So the oxalic acid, how much we got it here? 0.005, right? So mole here also the same, 0.005. So which is the correct option? The option it is D option is correct option. Yes, option D is the correct option. Option D is the correct option. I hope you got the clarity. See how indirectly the question it is. See, they have given that reaction. In that number of moles, it is mentioned very clearly. So moles ratio we have to identify from that molarity. So number of moles of solute divided by volume of solution in liter. That is the concept. Now, how do we bring it this point? This is simple. Like what to say, molarity equal to number of moles by volume of solution liter. So number of moles we can bring it out, means molarity into volume of solution. So that is the way. Now here ml we just converted into liter, then multiply with that, so you will get the correct answer. I hope you got the clarity. So before finding this answer, we have to find the moles ratio according to this point. Come on, let's go to the next question.